So now let's look at how all of this works with rational functions. Again, rational functions is where we have a function of some sort in the numerator and the denominator. So we see our variable x showing up in both spots. So again, in terms of kind of visualizing a framework here, we have g of equals, we're going to take 2 minus that input over the input plus 4. So inputting 0, I'm going to have 2 minus 0 over 0 plus 4. So with that, we'll have 2 over 4, which would reduce down to 1/2. I know this one here is a simple fraction, but in case you get to messy fractions and you're unsure whether or not they simplify, in the Desmo Scientific Calculator, I really like that you can type in your fraction. It'll give you the decimal form automatically, but what you can do is click this little convert to fraction button and it will show you the reduced form. So if you think you have it reduced but you just want to double check, plug it into Desmos and make sure. Alright, g of 2, so what we're going to do is have 2 minus our input of 2 over input of 2 plus 4. So in the numerator we'll have 0 and the denominator will have 6. And when you have 0 in the numerator, that just makes an overall value of 0. Plugging in -4, we're going to have 2 minus -4, and then a -4 plus 4. So in the numerator, that's a 2 plus 4, so you'll have 6 over -4 plus 4. And we're getting 0 in the denominator, and that can't happen. So with this, does not exist. So this is to show that with rational functions, we might have cases that won't work because our domain's going to be limited. It's going to be specifically limited by the fact that we cannot have 0 in the denominator. Make a note of that. Cannot have 0 in the denominator. In the numerator is fine, as we just saw in that first example, or second example, but in the denominator we can't divide by 0. Okay, so that's just plugging in values, but what if we want to plug in an expression? So I'm going to take my framework of 2 minus the input over input plus 4, and my input's going to be this entire expression of 3x minus 1. 3x minus 1, 3x minus 1. Then we're just going to start simplifying. So in the numerator, I'm going to distribute this negative. So I'll make it a 2 minus 3x plus 1 over, and then the denominator, those parentheses just drop, so 3x minus 1 plus 4. Then we'll have 2 plus 1 is 3, and then minus 3x over 3x plus 4, so the -1 plus 4 will give us a positive 3. Something you might notice here is that there are common factors of 3 all over the place, and if you have a lot of practice with these rational functions and rational expressions, you're comfortable canceling, go for it, but most often the canceling goes wrong. But you can always think about factoring. So like in the numerator, if I just look at that 3 minus 3x, I can see that common factor of 3. So I can factor that out, and that would leave us with the 1 minus x. And then over, and then the denominator, I can see that common factor of 3, which would leave an x plus 3. And then I can really see that through multiplication and division, those would just cancel out with each other into a 1. So completely simplified, this would be 1 minus x over x plus 3. So if you're comfortable canceling at this stage, you can. Something that often happens, like right here, is canceling that 3. Sometimes students write a 0 there, but when canceling cross division, it'll leave us with a 1. Alright, now let's look at a messy fraction. Or the real term is complex fraction. So we're going to start to see fractions within fractions here. So we're going to have 2 minus our input over input plus 4. And our input is going to be this entire expression of 2 over x plus 1. So I'm going to have 2 over x plus 1, 2 over x plus 1. So what we're going to do is we want to take a step to eliminate these denominators here. So if we had multiple denominators, what we would do is look for the least common denominator. In this case, we just have the same denominator, which is really nice. So what I'm going to do is I'm going to multiply by a version of 1. I essentially want this fraction over here to equal 1 so that I'm not actually changing anything in terms of value. So whatever I put in the numerator here, I have to put in the denominator as well. And what I'm going to choose is what's showing up in the denominator, so that when I multiply, those denominators will cancel out. I essentially want to wipe out those denominators that are popping up within the fraction. So I'm going to use that x plus 1 and x plus 1. So what this will look like is, and let me even put parentheses there, because what's going to happen is this x plus 1 is going to distribute and distribute. So in super long form, I'm going to write it all out. We're going to have 2 times that x plus 1 minus that 2 over x plus 1 times x plus 1. So that's how the x plus 1 distributed in, over, and then the denominator will have 2 over x plus 1 times x plus 1 plus 4 times x plus 1. So absolutely everything got multiplied by this factor, and that's what keeps it balanced. We haven't changed the value, we're just trying to change the appearance of things. So now with these fraction pieces, these rational pieces, those x plus 1s will cancel out with each other. So then what I have in my numerator, I can distribute that 2 in, so 2 times x plus 2 times 1, so 2x plus 2. And then all I have left from the cancellation is this minus 2. And then over, with the cancellation, all I have is 2 left over. And here I'm going to distribute 4 into the parentheses, so plus 4 times x plus 4 times 1. So now I have simpler values in the numerator and denominator. I don't have fractions within fractions anymore, so it's easier to simplify. So in the numerator, that plus 2 and minus 2 will just turn to a 0, so we'll have 2x over, and then 4x plus 6. And simplify this just a little bit further, kind of like we did with the last example. What we can notice is there's a common factor of 2 within each of the terms. So again, you can either look at the factored form, so like 2 times x over 2 times 2x plus 3, or if you just know how to divide out 2 from each term, you can do that as well. So this will be x over 2x plus 3. And then we're done. Alright, let's get our practice with solving equations. So we're going to have our function, which is 2 minus x over x plus 4, and then that's going to equal 2. So what we're going to do is multiply both sides by the denominator, so that on the left-hand side, that'll cancel out, so then all we have left is the numerator. And then on the right-hand side, we can distribute that 2 in, so 2x plus 8. Now we don't have denominators anymore, so in this case, it's something linear that we can solve. So I'm going to add x to both sides. So we'll have 2 equals 3x plus 8. And then I'm going to subtract 8 from both sides. So we'll have a negative 6 equals 3x. Divide both sides by 3 for a negative 2. Now again, this is a case where our domain's limited, so we need to check our answer to make sure it's not extraneous. So we can do is plug in the -2, so taking 2 minus -2 over -2 plus 4, and see, does that equal just +2? So in the numerator, 2 plus 2, we're getting 4. In the denominator, -2 plus 4 is 2, and that does equal 2. So that checks out. Our answer is good. Let's take a look at the graph of this. So our rational function looks like this, with the red lines there. So there's going to be this spot where it's undefined, and you can see it's occurring at that -4 that we plugged in, and that's because that's the one number that makes that denominator turn to a 0. So basically we just can't solve for an output where -4 is for x. We wanted to see where this equation intersects with 2. So if I graph the function y equals 2, I can see the single intersection occurring at -2, +2. So there's my x value of -2 that we just solved for. Alright, let's look at the next one. So our rational function, 2 minus x over x plus 4, we're setting that equal to x plus 3. We're going to do the same thing. I want to get rid of that denominator, so I'm going to multiply both sides by that denominator of x plus 4. I'm going to be sure to put parentheses because I want that entire x plus 3 to be multiplied by the x plus 4. So on the left-hand side, the x plus 4s will cancel out, so all I have is 2 minus x. On the right-hand side, I need to FOIL. So we're going to do first, outer, inner, last. So x squared plus 4x plus 3x plus 12. So I have something quadratic, so I'm going to want 0 on one side of the equation. Before I do that, I'm just going to take a step to simplify the right-hand side, so adding those like terms. And then what I'm going to do is add x to both sides and subtract 2 from both sides. So I'll have 0 on the left-hand side, and then on the right-hand side I'll have this x squared plus 8x plus 10. Now, factoring this, I would look at the factors of +10 and see which add up to 8. But what we're going to see is none of them do. We get close with that 7 there, but not quite. So let's review our quadratic equation. We haven't done that yet for this class, but there's no time like the present. Alright, so our quadratic equation goes that we can solve for x, and we're going to have -b plus or minus the square root of b squared minus 4ac all over 2a. So for our quadratic equation, we're going to go a equals 1, b equals 8, c equals 10. So let's use our quadratic formula. So we're solving for x, and we're going to have -b, so -8, plus or minus square root of b squared, minus 4 times a, which is 1, times c, which is 10, all over 2a. When I simplify this, I think of it in kind of 3 pieces. I think of the -b part and knowing if there needs to be any simplification there. I like to simplify this square root piece all in one go, and then you have the denominator. So for us, we have this -8 plus or minus, and then I'm going to go ahead and simplify that square root. So this is a 64 minus 40, so that's going to be a square root of 24 all over 2. To simplify further, I'm going to take -8 plus or minus, and that's square root of 24, and if it helps, you could do this off to the side. I want to look for, is there something I can get out of there in terms of a square root? If I think of this as 4 times 6, I can simplify that square root of 4 would come outside as a 2, square root of 6 would be stuck underneath and over 2. But by simplifying in that form, then I can see this common factor of 2 that I can take out. So I can divide out 2 from the 8 to leave me with a -4, and it can be divided out from that square root piece. So this is all going to simplify to a -4 plus or minus square root of 6 for an exact answer. And if you want the decimal, you can just plug that into the calculator. So if you need review of this, check out, I don't have any uploaded for this class, but there are plenty online for using the quadratic formula. Let's look at the graph of this real quick. So we have our graph and a graph x plus 3. I can see I have these 2 intersection points. So that's where we have the addition or subtraction, and it gives out those 2 different answers there. If we plug those into a calculator, then we could see our decimal form of those answers. So there's our rational functions.